All right, good morning. So we're going to go over the first two problems from the work from today. So here we go. So this question is actually the question from the worksheet from yesterday. So I want to do this one first, and then we'll look at the one below that, and we'll do the first two together. If you are stuck at any point of this, um, just let me know. To remind me, go over our second, part with you. So if we look at this one, we have I1, I3, and I5 are given. We're trying to find I2 and I4. So what we're going to do is we're just going to set up several equations at each junction. So here are all of our junctions in green. Okay. And then we'll set up what's going on at each one. Okay. So we know Kirchoff's law says that all the current going into a junction must equal all of the current going out. So if we look at this first one, we'll do this one up here. I1 is going in. So that must be equal to I2 and I3. All right, I1 goes in, I2 and I3 go out. Let's do another one down here, change the color. Okay, so for here, this is the opposite. And this one, I2 and I3 enter, and that gives us I1. Okay. All right, so we'll do this one in red. All right, and we'll do the same thing over here. We'll do this one in blue. All right, and this one, we have I3 goes in, and I4 and I5 go out. And it's the same thing down here. It's this, it's just written backwards. Right here, I5 plus I4 both go in, and they equal I3. That's this guy right here. Okay, so those are our four equations, and we really only need two of them because these two, the green and red one, are opposites of each other, and so are these two over here. So if we just focus on the ones on the bottom, because they're the ones that I think are a little bit neater from my handwriting perspective, let's solve them based on the numbers we have. Well, we're given that I1 is 20. We're given that I3 is 12. All right, so I2 is X. So we solve for X. X is 8. Okay. Same thing for this one. All right. We're given that I5 is 7. All right. We don't know I4. And we know I3 is 12. So if we work backwards, we bring the 7 over here via subtraction, and that tells us this is 5. And that's how we get it. So I2 is 8 amps, and in this one, I4 is 5 amps. That's question 1. All right, so let's go down and look at this one right here. All right, same idea. So we're going to set up an equation for every junction. So for this one up top, all right, we'll do them and we'll color code them. This is I1 equals I2 and I3. Okay. This one, okay, is I2 equals I4 plus I5. Okay. I2 and I4, 5 out. All right, then we have this one here. This is a big one. So this one is I5, I3, I4, and they all equal I1. Okay. And those are our 3 junction spots. That's all the ones that we've got. All right. If we look around, right, there's nothing else really here. That's a junction. So we go back and now we can solve. So we know that I2 is 20, I3 is 6, and I4 is 8. So if we know 2 and 3, okay, we can get I1. So we're going to do this top one first. Okay, so if we plug everything in for this first equation, okay, I1 is what we're looking for, I2 is 20, I3 is 6, so that means I1 is 26. Okay, so we know I1, we know I3, we know I4, we can get I5, so that's the one down here. Okay, so I5 is X, I3 is 6, I4 is 8, and I1, we just found out, is 26. All right, 6 plus 8 is 14. We bring it over. 26 minus 14 gets us 12. Okay, that's I5. All right, and this is I1. So if we know, so now we know that. So now we know I5 is 12. And we know I4 is 8. Okay. That would mean that 12 plus 8 is going to give you, oh, nope, I'm sorry, I have this one step backwards. Oh, no, yeah, we already said 8 plus 12 is 20, and I2 is 20. So we've actually proved that this all works. I'm sorry, I got myself confused there. Okay, so there we go. So that's the first two questions. If you have questions on the second two on the back, again, shoot me a reminder, let me know, and have a good one, guys.